Whew, okay, hey y'all. We are going to finish 13.5. Okay, let me hide this, zoom out slightly. Okay, so we're right here on problem 7. So problem 7, we're probably saying, does not look like a difference of squares problem, obviously, because it's a trinomial, right? 8's not a perfect square, and there's 3 terms, right? So I'm actually going to show you how in this section they're kind of, okay, so it's called special factoring, right? It doesn't necessarily mean every single problem is going to use difference of squares. I think there honestly may just be 2 or 3. And what they're going to do is this right here that I'm going to show you. It's just called special factoring because there's only certain times that you can do this, okay? So the AC method part of this, because that is a trinomial, it is in the correct form, is completely the same that we've already learned, nothing different, no surprises. Let's go ahead and do that. That will end in factoring by grouping. And then that last step is going to be where you see it's just a different way to write an answer if you can, okay? So because this is a trinomial, my A is 1, my B is -8, my C is 16. A times C is 1 times 16, which is 16. Factors of 16, 1 and 16, 2 and 8, 4 and 4. I'm done, right? So I need to know what pair of factors will combine together to give me a -8. Well, 4 plus 4 is 8, right? It needs to be a -8. So if I make them both negative, those still multiply to give me a positive 16, and they'll combine together, right? Signs are the same, add and keep. That's my B, that's what I want. So those are going to be what I use to expand this B term, okay? What I have is x squared, that's a -4, don't forget your variable. And then we have another -4, don't forget your variable. And we have a positive 16, right? So my steps for factoring by grouping, split down the middle, they only have an x. Let's divide. X squared divided by x is x. 4 divided by 1 is 4. Signs are different, so it's negative. X divided by x goes to 1. Bring down your sign. The only thing those two terms have in common is a 4. Let's divide. 4 divided by 4 is 1. X divided by no x is x. 16 divided by 4 is 4. Signs are different, so it's negative. Close it. Do my parentheses match? Yes. All we need to do is just write down one of the parentheses, right? And then we're going to look and see what was left, right? That second term right there, make sure you include whatever sign is with it. They're actually going to share a parenthesis together. So that's all of the AC method that we did previously. Here, the couple of problems that you'll see in this form, you go ahead, you do the AC method, you can get it to factor into our 2 parentheses, right? Our 2 factors. And now what they want you to notice is that both of those factors are completely the same, right? They're 100% identical. The first value in each is just an x. They both have a negative sign, and then the second value in each is both a 4, right? So if you input this as your answer, it would probably say, oh, your answer is equal to the correct answer, but unfortunately, it's not correct. And that's because what they want us to do is square it, okay? This would be considered an expanded version of this condensed version, okay? Technically, that would be a combined, right? I'm taking both of these because they're exactly the same, and I'm saying we can square it. Because if I did see it being squared, I would say, oh, that's my base, and it's saying to multiply it to itself twice. Okay, that's literally it, y'all, for those couple of problems. And you can only do that if they are the exact same. When they are, of course, mathematicians inherently lazy. If there's any way at all I can shorten something or, not have to write something multiple times and, where it becomes redundant, then I'm going to shorten it. So that would be your answer right there. Okay, it's just this right there. Okay, let's look at our last problem for 13.5. It's kind of weird how they go right back into the process we were doing, but they do. I'm looking at this, and it's not very easy to tell if both of these are squares. I know that I can go ahead and start taking the square root of everything, and if it works out right, if my math it works out, then it does end up being a perfect square. Whenever I try to take the square root of 2 and I use my calculator, I got a decimal, right? I'm going to go ahead and take the square root of these. If I get a whole number, when I take the square root of something, that means it is a perfect square, okay? So let's go ahead and identify what we have here. Our a squared, sorry, it looks like a 9. Our a squared is x squared. I know I need to take the square root of a squared, which is x squared. I know that this can be written as exponent over root, which just gives me an x, which is my a, right? Then I know that I need to look at my b squared, and that value is a 1 over 9. I know I need to take the square root of b squared, which is 1 over 9. Now let me introduce this new rule to you right here. If you have a large radicand, if you have a big, square root, cube root, we're just going to do square root, but so let's just say we're taking the square root of a fraction. Okay, what you can do is actually take the square root of the top and the square root of the bottom. Okay, and that's what it's showing right here. It's square root of m over the square root of n. So let me go ahead and do that, right? Because if you use your calculator for one, the amount of parentheses you're going to need to just keep the numerator and denominator separate is already going to be a hassle. But I'm telling you right now, you do not get a whole number. So I don't want you to think, oh, that's not a perfect square. I can't use difference of squares. Let's actually apply this rule and see what happens then. Okay, so it told me, wow, that was actually quite incredible. Thank you. Right here. Nope. Zoom in. Okay. Oy vey. It told me that what I can do, there we go, is I can take the square root of my numerator over the square root of my denominator. If you take the square root of 1, you get 1. Whole number works, keep going. In the denominator, if you take the square root of 9, you get 3. Whole number, it works, right? This is my B. Using our template, it does not matter which one's negative or which one's positive. My A is just X. My B is 1/3. Just because there may be some doubts here, what I'm going to do is actually FOIL this one out, okay? So if you do X times X, keep and add. Can y'all even see that? I'll do this like light blue. If you do X times X, you keep and add. If you do X times 1/3, you get a positive 1/3 X. If you do a negative 1/3 X, you get a negative 1/3 X. If you do 1/3 times 1/3, 1 times 1 is 1. Signs are the same. Oh, sorry, signs are different, right? I'm sorry, I don't know why I said that. So it's negative. 3 times 3 is 9, right? What I wanted to do was just say 1 times 1 is 1 over 3 times 3 is 9. Signs are different between these two terms, so it's negative. So right here, I get a negative 1 over 9. Then I notice additive inverses, those cancel. And so what I have left is x squared minus 1/9. X squared and a negative 1/9. So there you go, y'all. That is how you do 13.5. We only have one more section left. If y'all have questions, make sure you ask, okay? Thanks. Bye.